Hey, good morning again. It's December 1st, and this is our second video of the morning. This video will take a look at calculating t-scores, running a single sample t-test. So I will start by sharing my screen, and we are going to take a look at excuse me, an Excel document that is full of a ton of data. So I want to go through it with you and take a look at what's going on. I've actually am working multiple things within these sheets, so we'll take just a second and go through them. This original tab, my OG star combined data. This is my master copy. For the original, because I have learned, as I stated before, that if you don't make a copy, you're setting yourself up for failure and 2 to 3 times the work and time investment. So, good habit to get into practice of. Um, this sheet we'll come back to in just a minute. This is going to be the meat of the video and what we talk about. And what I did with this was narrow this down to one grade level 1 test, and we'll talk about why in a little bit. I will make reference to my technical digest cutout snippet here, and this is going to give us some basic data to start working with for my selected sample group. We make reference to critical t-values. You can go online and find critical t-value charts in all shapes, sizes, and formats. Basically, regardless of what charts you pull up, they're all going to have the same components, which would be degrees of freedom, your significance level, which could be a number of things. In education, we're going to set our confidence interval at 95%, which means we'll have an alpha of 0.05 because we don't have to worry about killing people with our data. We make important decisions, but they're not life or death. I have the sheet that I'm going to skip over because I'm going to use the same data in a little while when I demonstrate paired test or 2 samples. And then I have this Pearson R, which is where I worked before. So we won't use that during this video unless we need to make a prior reference. I also have a snippet of a normal distribution curve, which you can pull off the internet, again, in various forms. It just helps us interpret our statistic values, our test statistics, to see whether or not we're going to reject or fail to reject our null hypothesis. So let's get started. What I did was I weeded down some data and I kept my unique student ID. The grade enrolled, I'm focusing on 4th grade. Gender, I have female and male. And to narrow down some more, I focused on the white ethnicity or race. And then I just left county district information in there because I'm going to be looking at one particular county, district, data campus, etc. I also have students' raw scores on here, their scale scores, and then I have a dummy data set, which we will talk about in just a little while. So let's get started. In this research process, it's a 6-step process, and what we need to do to begin is to develop a question that we're going to work with. So what I did was I wanted to compare the raw score mean for the white population in this one particular district on the grade 4 reading start exam as compared to the population of the entire state of Texas 4th graders, all white students. So my research question, I'm going to scroll over a little bit. Scroll over too much. I appreciate your patience while I get back. My research question basically states, is the raw score mean for the white population of the 2017-2018 STAR test population being the entire state of Texas, significantly different than the white population at District X, which is what I'm looking at. So again, I'm comparing this district as opposed to the state of Texas. All fourth graders, all white students, all reading test, all 2018 testing year. So in order to figure out if there's a statistical significant difference, I have to pick a test. And in this instance, I'm going to use a single sample t-test because I want to compare if the population mean is different than the sample mean. For this situation, we're going to pretend like we don't have the population standard deviation. However, in many cases, you will have that, specifically if you're looking at STAAR test data, you can get that information from the technical digest, which I made reference to earlier. So the next step is checking our assumption, and our assumptions are three-part in nature. One is we have to look at, do we have a random sample? And yes, we have a random sample. Although I selected a district, I did not choose who was enrolled in that district. I did not choose who was enrolled in fourth grade or when they were in fourth grade. I did not choose anything about these students. So these are students that would have enrolled in this district regardless if I would have been a part of this test or not. Is this independent of the observations? Yes. And lastly, our dependent variable is normally distributed. Well, we're going to figure this out by running histograms and box plots. As you get more advanced in statistics, there are other ways that you can check this and other tests you can run to look for normal distribution, but we're going to stick with histograms and box plots. So let's take a look. All of this is done through data analysis, and there are various things. So the first thing I did was create a histogram to look at my raw scores. And you can see that there is a curve. We don't know where the normal curve is at this point, which way it's slanted. You can look and make assumptions, but we never truly know until we run test statistics. So across the bottom of this, you see raw scores, and the frequency of occurrence. So these are my raw score frequencies for sample. Again, data analysis allows us to create a table for bends in frequency. I apologize, I'm using a different computer than normal because of technical difficulties with the other one. However, like I said, I use my histogram to create a bend frequency chart. I had created the bend on my own, as you can see later in my data. When it decides to pop up, I created my own bend, and then I copied it and pasted that and ran my frequency. Let's go back. Next thing I want to do now that I have determined what test I want to use is I want to create a hypothesis. And you have to create a null hypothesis and an alternative hypothesis. The null hypothesis, known as 0, in this case says that the mean of white students for the population, that means the entire state, shows absolutely no difference than the mean population of my sample, which is the white students for this one particular district. So there is no statistically significant difference in the means. Conversely, your alternate hypothesis, which you also need to test, states that there is a difference in means for the population of the state versus the population in my sample. So after I've listed my hypothesis, the next thing I need to do is select a test, which we'd previously referred to. In general, we said that we wanted to look at a two-test, but we need to be specific here and narrow it down. We're going to use a two-tailed test because your deviation and your correlations and your statistics could go one direction or the other. So we're going to run a non-directional test and see where it takes us. we're setting our alpha at 0.05, which is the same as the confidence interval of 95%. And as I stated earlier, we can do that because we're in education. So we have more room for error than we would if we were working with life or death, say in the medical field, in which case you would set a different alpha and have a higher confidence level. The next thing we're going to do is calculate the statistic using these t-tests. So some important numbers, you look where I'm pointing here. N, notice it's a lowercase n because that's my sample as opposed to an uppercase N, which would be the state population. So my sample included 238 students. Next, you take your degrees of freedom, which is your sample size minus 1, and it gives you 237. And then your TCV or your T critical value, you'd make reference to this chart I showed back here. And just going back to it, I like the degrees of freedom, and I come up with a critical value of 1.96. So I'm going to need this data to run my statistics. And to briefly show you, we went into data. It's going to be slow. So it's data analysis, and then you can search for a t-test. Not quite sure why it's not popping up here, other than it's being slow. But when you pull up the data tab, it gives you a few different options for samples. And although it says all these options, it shows our two tests, we're going to make our data work even though we have one sample. Creating dummy data. So dummy data, all of the research books and any videos I've watched and anything I've learned says you normally only have to put a set of 2 data points. But when I tried to run my data test, it was telling me it couldn't make the connection between input and output, and that my samples didn't match up. So what I did was I just quickly went through for all 238 samples and had a dummy data point to match. So theoretically, it's looking for a 1-to-1 correspondence. Since I set this dummy data at 0, it'll allow me to perform the 2 tests, or the 2 sample tests rather. And then once I get my information, which I did over here by running t-test paired sample, 2 samples for means, in this column right here, it had dummy data and I just went through and deleted it. So let's talk about what this gives me. And before we do that, let's run over here. And I'm sorry for not pointing this out earlier. As I told you in my sample size, which is this district of 4th graders, I had a population of our sample size of 238 students. If you look at our population, the capital N, this is for the entire state, there's 108,447 students. So using the technical digest from the TEA website, I went to the 1718, and I apologize, that should actually show differently. I just didn't change it, but you go to the technical digest and I pulled up the test scores for 1718 to match my data, and it gave me a mean and a standard deviation, but we're pretending like we didn't have the standard deviation, and it gave me a mean p-value. So now I'm calculating, and when I calculate my statistics through data analysis, t-test paired to sample for means, you'll see I came up with a mean of 23.38. Well, you notice back here on my population, I had a mean of 25.85. And it gives me my variance, the observations we had put in, and a hypothesized mean difference, which we would use later to take a look at further statistics. My degrees of freedom, 237, because it's 1 less than my number of observations or student participants. And then it gives me a T statistic. And then you can see I have T criticals for the 1 tail and the 2 tail, and P values for the 1 and the 2. So let's talk about these a little bit. The ones that I want to focus on is this T statistic which you can see has a negative number, and being a -5 on the normal distribution curve, we can kind of go through here and look. And if we're at -1, -2, -3, my -5 is going to be way, way, way out here, which tells me that I'm going to reject my null hypothesis. But I can't just stop right there. So I'm going to go back to my data, and the other 2 points I want to focus on, because remember I told you needed to focus on 3, your t-stat, and then we want to look at our p-value and our t-values. So our t-critical values. So looking at this p-value, we want it to be less than t, and our critical value is 1.97, and you'll notice this 2.40 exponential to the -7 tells me that it is a difference, and I'm going to fail to reject. No, I'm going to reject the null because of where it falls. Let me see. So the next thing we want to do is interpret results. And I basically just told you that I'm going to I'm going to reject my null hypothesis, which said there is no difference. So in this district, excuse me, there is a statistically significant difference in the population mean versus the state of Texas for grade 4 white students testing in reading. The next thing we need to do is go through and look for a Cohen's d. So you can go into formulas and go into Cohen's d for single sample t-test. And using that, we came up with a number that is -5.31 my t-stat, because it's the mean of the population minus the mean of the sample over the standard deviation is the formula for that. And your t-stat needs to always be less than your critical value. So when I get a Cohen's d number, which I thought I'd placed in here somewhere, my Cohen's d number also matched up with needing to reject the null hypothesis. Let's see. Looking through my notes to see if there's anything else I need to add for this. And just to add some extra notes, when you're calculating your statistic, your t-critical value, like we said, we got from the chart. You can run your t-test one sample in Excel by using a paired 2 sample, creating data. It's going to ask you for variable 1 and variable 2. Variable 1 is your raw scores. Variable 2 is your dummy data. Hypothesis mean difference, you're going to use your population mean difference, which we got from the chart. It's going to ask you if you want labels, which you do, and then you're going to set your critical value. You can either set it on the chart or you can set it in a new worksheet. And mine kept having instances of where it was conflicting with my data, so I just put it in a new worksheet and it was able to show up. To get your standard deviation when you go into data analysis, you can also click on a cell and you can go in and you can type a formula, STTEV for standard deviation. There are a couple of different versions. You want the point S, but it'll pull up. And in order to get that, then your data you're going to use, you're going to highlight your raw scores. Custom filters are how you sort your data. And then once you get your t statistic and your critical values, you're going to compare it again to your normal distribution and see where your numbers fall. And all of my statistics fell in the reject the null hypothesis, which means that they didn't occur within the 95% confidence level or the 95% of the population standards. and then you interpret your results and you go from there. The cool thing, as always, is that with this set of data, you can do infinite things using either formulas, inserting various charts. You can use data analysis to get things, to get any kind of statistic you could possibly ever about the box and plot, or the Whisker box plot. And the reason why you do this is because, like I said earlier, even though I can see that there appears to be a normal distribution, this is what I need to look at it, because this right here is going to show your mean average. And then you can see right here that where my statistics fall, I can see a normal distribution falling on either side of the mean average. This, you can go through this chart and just add labels, and that's about all I have. It's a little overwhelming as to what you can do with all of this data in Excel, but we will continue to learn and grow together. Thanks for joining me.